All right, Bismillahirrahmanirrahim. Assalamu alaikum. Students, we are going to proceed with the type 1 problem over here. And if you look at it, this problem, the uniform crate shown in the figure, they have basically showing us the uniform crate. Okay, this is our crate. That has a mass of 20 kg. Okay, the crate mass is 20 kg. If a force of P is equals to 80 Newton, this force P is equals to 80 Newton is applied to the crate. Determine if it remains in equilibrium, and the coefficient of static friction given to us is mu s equals to 0.3. Okay, this mu s basically lying between the crate and the floor. Okay, this is in between, it will lie as a friction coefficient mu s equals to 0.3. The S stands for the static coefficient of static friction, S. If it would have been dynamic kinetic, we would have written mu k. So the dimensions are: length is 0.8 meters, and from the floor to the height from the where force is acting is 0.2 meters. This force 80 Newton is making an angle 30 degrees with the x-axis. So the first thing is that if you look at it, the data given to us is mass equals to 20 kg. The force P is 80 newtons. This is the applied force. Okay, and this is the force in the diagram. If you look at it, this force will create the motion. This will create the motion on the crate. Mu s is the 0.3, the coefficient friction between ground and the crate. The unknown parameters, if you look at it, we have to draw the free body diagram of the crate. Okay, so the unknown parameters are, what are those? If you look at it, it is the normal direction, the friction coefficient, and the friction force, and x is the distance from the origin that we have considered the center of the crate as the origin to the point where the normal force is acting, which is x. Okay, so basically if you look at it, we have basically this is the weight, this is the 80 Newton force. So first of all, we have to decide from this data whether it is what kind of a case type 1, whether it's type 1, type 2 or type 3 problems. Okay, so if you look at it, we will see that from here we will see the number of unknowns. The number of unknowns. The number of unknowns is equal to, how many number of unknowns we have? 3. Okay, we have the 3 unknowns. What are those? The NC, the X, and the friction force. And as always, equations of equilibrium will be equals to 3. So as number of unknowns, okay, so unknowns, number of unknowns is equals to equations of equilibrium. So how many? 3 is equal to 3. So this scenario basically tells us that it is a, what kind of a problem? This is a, since this is a type 1. Okay, this is a type 1 problem. Okay, this is a type 1 problem. Okay, so we have decided, now we have to proceed in a type 1 problem. How to proceed? We know, if you look at it, if on this in the type 1 problem, what really happens is that this is remember, this is the point, this is the this point, it is the point of impending motion. Okay, this is the point of impending motion. Okay, so in type 1 problems, the body is always going to stay in this zone. Here, it will be always in this zone, and this zone is basically the zone of no motion. This has already been decided. We have discussed this in our theory lectures and in our that the body is going to be staying in this zone. It will not be going at reaching the impending motion point, where the basically which is the maximum point of static friction. Okay, so it's not going to reach it. It's going to stay in this zone. So once this is being decided, now we can with all these facts we can proceed with our respective numericals, how to solve it. Okay, so what does he says? He says that the uniform crate shown has a mass of 20 liters. So we have given the data. This is the data. The unknown parameters are decided. Number of unknowns are 3. Number of equations are 3. Applied force is P. And basically, as crate and dimensions are given, we could solve for X. Okay. So basically, we have to because the dimensions. Remember, the dimensions as dimensions are given in this problem. You see these dimensions 0.2 and 0.8. We have to check for. So we'll start checking it first of all for that whether this force P is going to create a tipping point. It's going to tip, and when we can easily say the point of tipping will be which will be the point of. I think it's going to be this end point. We can assume this is the point of tipping. Okay, and this point, remember, is basically 0.4 meter. Okay, 4 meters from the origin. So if you look at it. The equilibrium equations we have are sigma fx equals to 0, sigma fy equals to 0, and summation of moments equal to 0. So step 1 is first of all is apply the equations of equilibrium. If we apply the equations of equilibrium and before basically applying the frictional value at the impending motion point, we have to apply the equations of equilibrium. And one more thing which is very important for this force is always remember that it will have two components. Okay, one component will be this one. This component will be how much? 80 cos 30, and then there will be another component. There will be another component which is here. Okay, it is here. It will be 80 sin 30. Okay, so when you apply sigma fx is 0, what do we get? 80 cos 30. Okay, this component acting towards the end. Remember one thing which is understood, but we must always remember that this is going to be our x-axis, positive x-axis, and this is our positive y-axis. So this is our positive x-axis and this is our positive y-axis. This is our positive x and positive y. So we cannot assume the wrong direction. So 80 cos 30, and what is the direction of this friction force? F. What is the direction of this friction force? F will be, it is towards the negative x. This friction force is basically towards the negative f. So we write minus f equal to 0. From here we can easily calculate f equals to 69.28, because we multiply 80 with cos 30, we will get 69.28, and basically we can take this minus f on the other side, so we will be getting a value of f equals to 69.28, which means this friction force, okay, that we have is basically calculated. We have calculated this friction force. Now we apply sigma fy equal to 0. When we apply sigma fy equal to 0, we will have basically 80 sin 30, this component 80 sin 30, but the direction of 80 sin 30 is against the direction of positive y-axis, so we write it as minus 80 sin 30. Then we have this normal direction, which is whose direction is towards the positive y-axis, so we write plus nc. Then the weight is again in the opposite direction towards the positive y-axis, so we write minus 196.2 equal to 0. So we get again calculate the normal reaction. This one, this is our respective normal reaction we have calculated. This is already calculated. So we have got these two unknowns. So out of the three unknowns we have got these two unknowns. Now our next target is to calculate this value of x. We have to calculate this value of x. How to calculate x? How to calculate this x? We have to calculate x. So what should we do? Basically, when we can only calculate x value, when we assume that this force of 80 Newton is going to create a tipping in this crate. So with this done, now we basically check for the tipping. So what we do is we assume that this is the point O. At this point we take summation of moments at O equal to 0. So if we take moments, again remember our two components of the force, this one is this component and the other component will be this one. This component, okay. So 0.48 sine 30, it's the vertical component. What is the distance from O? Because we are taking moment summation at, remember, we are taking the moment summation at which point? We are taking the moment summation at O. So it will be 0.480 into sine 30, okay. So the value will be 80 sine 30 and the perpendicular distance calculated is 0.4. This is going to be 0.4. This is 0.4 from the origin. What about, and again if you look at it, this 80 sine 30, if you look at it, is going to, since we have taking very important point, we are taking the moment summation in which direction? In anti-clockwise direction. So what does that mean? That means basically anti-clockwise movements will be positive. If you look at it, it will be positive. So 0.480 sine 30 minus, this is going to be anti-clockwise, and this 80 cos 30, this component is going to tip the body. If you look at from the origin O, this component is going to tip the body in this direction. This is a clockwise direction. This is a clockwise direction, and clockwise directions are always negative, okay. The clockwise directions are always negative since we assume anti-clockwise direction as positive. So it comes out to be minus 80 cos 30, this component, and the perpendicular distance of this component from the origin is 0.2 meter. It's 0.2 meter. Then this component NC, normal direction. This normal direction is this NC, and its distance from the point O from which we are taking the moment summation is x. So NC into x. Again, if you look at it, this NC has the tendency to rotate the body in the anti-clockwise direction. This is the anti-clockwise direction. So you can say that it's going to be positive, and x is the moment arm. So from here you multiply 0.4 into 80 sine 30 minus 0.80 into cos 30, multiply 0.2, and you can take this NC times x towards the other side. So both sides you can cancel the this gets cancelled, and you get the value of x equals to so you get getting the value of x equals to minus. So if you look at it, this will basically not get cancelled over here, because this is plus ncx, and this is going to be you can take it over there, it is minus ncx, okay. And if you look at it, this value is going to be it's because it is a positive x, it will go on the other side, okay. Okay, so here we have so we basically taken this ncx on the other side of the equation. If you look at it, we have taken it over the other side of the equation, minus nc into x, and plus 16 minus 13.856, it will give us 2.144. and what we do, we want x, so we divide it by nc, and the value of nc is minus 236.2. so we get the value of x is minus 9.07 into 10 to the power minus 3 meter. This value x equals to minus, this value if this value, again this is a minus value, but this tells us that this value has to be less than 0.4 meter. This value has to be less than 0.4 meter. So tipping will not take place, because remember this value is basically how much? 0. If the tipping would have taken place and the value of, if we the value of x would have, if the value of x, if the value of x is 0.4 meter, then tipping would have taken place. Tipping would take place. Okay, but since this value is, so since we know that here that x comes out to be minus 9.08, so no tipping. Okay, so no tipping. So tipping will not take place. This is very important. We will say that tipping will not take place. So we will say, as tipping is not taking place, we will now check for the slippage. Okay, whether this impending force P, whether this force P will able to create motion or not. So what we will do here is basically we will say check for the slippage. So we will say that the value of the friction that we have calculated, the value of the friction, this friction we have calculated was how much? 69.28 Newton. Okay, and this value is definitely somewhere below the impending motion point, somewhere below this point. You can see this is, and you calculated this value from the equations of equilibrium. Now what we will do is basically we will check our maximum point of tipping, and what is the maximum point of tipping is, which it is this point. Remember I told you it is this point. This is the point of, and at this point we know the friction will be maximum friction. It will be maximum friction, and you know what is the formula for maximum friction? The formula for maximum friction is going to be F max is equal to, you know, mu s into nc. So what we will do is basically we will put the value of mu, and it has to be mu s into nc, which is 0.3 into 2, that is 6.2. Now see, this value comes out to be 70.86 Newton. So what does this means? What does this means? That our friction force that we have calculated, was how much? It was, you can say F is less than F max. Since F is less than F max, what was basically F? If you look at it, our F calculated was 69.28. So it was 69.28, and it is less than, what is the maximum friction we calculated? 70.86. Okay, so what does this mean? This means since F is less than Fx, slipping will not take place. So final conclusion, our crate is going to stay in the no motion zone, in equilibrium of the graph, as F is less than F max. So it will not be so it will be below the impending motion point zone. So this is our conclusion. Okay, so I hope you have understood it, how to basically apply and solve the type 1 criteria theory, and then applying it to the numericals. Okay, so thank you very much.